Hey nerds, this is Suman and this is our today's integral. So just we have to solve this problem. So basically how we going to start this is we can actually proceed by integral x squared minus x squared plus 1 minus 1 plus 1 over x to the fourth plus 1, and here we have 1 over 2. So this term will cancel out and 2 by 2 is just we get the same integral, right? Okay, so after this we have 1 over 2. Let me do this as 2i here, right? 2i here, and I got integral x squared plus 1 over x to the fourth plus 1 minus integral x squared minus 1 over x to the fourth plus 1, and I have dx here and again dx is here. So up to there, I think there is no any kind of problem. And now then we can do some algebraic manipulation. I can write it as 1 plus 1 over x squared dx divided by x squared plus 1 over x squared minus integral 1 minus 1 over x squared over x to the square plus 1 over x squared, and here we have dx. So from here I can write 1 plus 1 over x squared dx, and this is x minus 1 over x squared plus 2, and here I can write 1 minus 1 over x squared dx over x plus 1 over x squared minus 2. If you open this, you will end up getting the same result up here, right? And now we have to just substitute. Why I had substitute? Because it is going to make some symmetry with here. If you differentiate this, you get this term here, and that's why I had to use minus here and plus here and plus here and minus here. So I would like to put x minus 1 over x is t, right? And after differentiating I get 1 plus 1 over x squared dx is dt, and I would like to substitute this also, and that is x plus 1 over x is z, right? And I get 1 plus 1 over x squared is dz. So our integral is going to be 1 plus 1 over x squared dx is going to be dt divided by this term x minus 1 over x is our t, and this is t squared plus, I can write it as the square root of 2 squared plus an integral again in terms of 1 minus, sorry, here is minus 1 minus 1 over x squared, I can write dz, and in terms of 1 plus this I can write z square minus 2. So this is going to be our 1 over root 2 tan inverse t over root 2, and this is going to be 1 over 2a ln z minus root 2 by z plus root 2 plus c, but we have our integral is here 2i, so it is going to be 2 and this is going to be 4. So I get 1 over 2 root 2 tan inverse. In terms of t, you can substitute x minus 1 over x minus 1 over x over root 2 plus 1 over 4 root 2 ln. In terms of z, you can substitute x plus 1 over x minus root 2 by x plus 1 over x plus root 2 with some arbitrary constant c, and this is the final integral of this. So up to there